Section 7.3, Simplifying Radical Expressions. Don't mind the green. It's there. I know how to get rid of it, but I currently can't because I have to stay off the internet. I am internetless right now. Alright, so objective 1, simplify radical expressions. So all we're going to do is just simplify. And that could be multiplying, adding, subtracting, dividing. It can mean a bunch of things. So here it says we're going to multiply. So when you have radicals, you just multiply the inside with inside and outside with outside. Alright, so here we have 3 times 5, which is the square root of 15. There is no such thing as the square root of 15, and it doesn't say to approximate, so that is our answer. Alright, here we have cube root. 4 times 2 is 8, and the cube root of 8 is 2. Because we can't simplify that more, we do. Alright, here we have fractions. That doesn't matter. You still go across, just like when you multiply regular fractions. So we have 2 times b is 2b, and a times 3 is 3a, and that's all over a radical. There's nothing you can do to simplify there because there is no square root of 2 or b, nor 3 or a. Alright, so here we have the square root of 5 over the square root of 16. Remember, if it's over one fraction and we're simplifying, you want to separate it. So we have the square root of 5 over the square root of 16. There is no such thing as the square root of 5, but the square root of 16 is 4. Alright, moving on. We have the square root of 40 over the square root of 81. So we have the square root of 40 over the square root, oh excuse me, no square root, we can simplify that. The square root of 81 is 9. But there is one thing that we're going to start doing is simplifying some more when we can. And what that means is we can take 40. If we break down 40 into its factors, that's 1 times 40, 2 times 20, 4 times 10, and 5 times 8. What we want to look for, after you list the factors, you want to look for one of them that has a perfect square. I take a week off and apparently I forget how to write. So you want to look for a set of factors that has a perfect square. Right here, 4 and 10, because 4 is a perfect square. So we're going to simplify that into the square root of 4 times the square root of 10, because that is the square root of 40, over the square root of 9, and now we can go ahead and take that square root of 4 out, which is 2. Then we still have the square root of 10 all over 9. And you can't simplify anymore because 2 and 9 have nothing in common. Alright, we're going to practice a little more with special types of simplifying. So we already know 40 is 4 times 10, which is 2 times the square root of 10. Alright, well, what about 300? 300 might be a little harder, so let's list the factors of 300. We have 1 times 300, 2 times 150, 3 times 100. Stop when you get a perfect square. You see how we have 100? That's a perfect square, so we're going to stop right there. Stop when you get a perfect square. So we're going to simplify this into the square root of 3 times the square root of 100. The square root of 100 is 10 times the square root of 3. The radical always goes second. It always goes last. Okay, now the square root of 15. Let's see what factors we have for 15. Well, that's 1 times 15, 3 times 5, nothing else. You see how none of those are perfect squares? Therefore, this cannot be simplified. So, can't be simplified, that's our answer. Alright, working with more variables. So when there is no index, it's always 2. Always. So now we want to, how many times does 7 go into 2? Well, 3 times. So that's 3 times. But when we multiply it, that's 6, but we need 7. So to get that 7, we have 1 left over. I'm actually going to do another example of that. We'll do C. We'll do B afterwards. So if we have x to the ninth, y to the third, and z. So when there's no index, it's always 2. So 2 goes into 9 4 times, and there's 1 left over to get 9. 2 goes into 3 once, and there's 1 left over. And 2 goes into 1 no times, so you can't do that. Okay. Alright, here we have the square root of 20 over the square root of x to the power of 16. Remember, the index is 2 if it's not there. So the square root of 20, we have 1 times 20, 2 times 10, 4 times 5. 4 and 5 is what we're going to pick because 4 is a perfect square. So we simplify this down into 4 times 5 over, and then 2 goes into 16 8 times. It goes into perfectly. So we have x to the power of 8. We can take the square root of 4, which is 2. We still have the square root of 5 left over x to the power of 8. Alright, moving into something a little different. You're going to see this again most likely the first 2 weeks of college algebra. The distance in midpoint formula. So they're formulas you are going to have to memorize because you will have questions on the test and you have to memorize the formula. Alright, example 5. We want to find the distance between negative 5, 8 and negative 2, 2. So the distance formula is the square root of x sub 2 over x sub 1 squared plus y sub 2 minus y sub 1 squared. It kind of looks like the slope formula, doesn't it? Because slope is kind of like the distance. It's the average rate of change. And distance is kind of like the average rate of change. So that's why they resemble each other. Alright, you always want to label your points. Remember, a broken record at the beginning of the semester, label your points. So we have x1, y1, x2, y2. And all you're going to do is plug it into the formula. So we have x2, which is negative 2, minus x1, which is negative 5, squared, plus y2, which is negative 2, minus y1, which is 8, squared. We're going to simplify this. It becomes plus plus. So we have negative 2 plus 5 is positive 3 squared, plus we have negative 2 and negative 8 is, what did I do there? Nope, it's not negative 2, it's positive 2. Boom. Okay, we're good. We have positive 2 and negative 8 is negative 6 squared. So we have 3 squared, which is 9, plus 6 squared, which is 36. That leaves us with the square root of 45. You always need to simplify as much as you can. So what that means is, let's see if 45 has a square root in it. So we have 1 in 45, and 5 and 9. I don't know any ones off the top of my head. So you can go ahead and stop there. You're always going to use 5 and 9. So we're going to switch this to the square root of 5 times the square root of 9, which is 3 times the square root of 5. So the distance between those 2 points is 3 times the square root of 5. Alright, example 6, we're going to use the midpoint formula. So the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. Because the midpoint is the middle. That's why we half it. So we add the 2 points together, right? If you wanted to find the distance between, like, say you're going to be driving from here to the Keys, and you want to find the middle point, you divide how long it is by 2, right? So label your freaking points. You better label your points. I can't make you, but you should. Alright, so we have x1 and x2, so negative 5 plus negative 2 all over 2, and then y1, which is 8, and y2, which is 2, over 2. Simplify each of these, so we have negative 7 over 2, and then 10 over 2. We can still simplify this 10 over 2, so we have negative 7 over 2, and 5. So if you plot these 2 points, the middle point is negative 7 over 2, 5.